Imagine pointing a telescope into the night sky in the 17th century and watching a moon disappear, not behind a planet or into shadow, but literally vanish. This wasn't a trick of the light or bad optics. It was Iapetus, one of Saturn's many moons, playing the ultimate cosmic game of hide and seek. In 1671, Giovanni Cassini observed a strange new moon orbiting Saturn, but he quickly noticed something odd. It was only visible on one side of Saturn. Once it moved around to the other side, it faded away like a ghost. That wasn't just puzzling, it was unprecedented. At the time, no one had seen a celestial body behave this way. Cassini had stumbled onto something extraordinary, and while we've learned much since then, Iapetus continues to defy explanation. With one half gleaming bright like snow and the other cloaked in darkness as black as coal, it's a world split in two. Stranger still, around its equator lies a ridge taller than Mount Everest, stretching over 1,600 kilometers long and rising 20 kilometers high. No other moon or planet has anything like it. So what's happening here? Why is Iapetus so dramatically two-faced? And what cataclysmic or cosmic ballet sculpted that bizarre equatorial wall? Today we'll journey across deep space and deep time to unravel the secrets of this hauntingly beautiful and strangely active moon. From dust trails to vanished mini-moons, from thermal feedback loops to ancient rings, you'll see how Iapetus became one of the greatest mysteries of our solar system and how it might still be crashing into Saturn's own cosmic systems. Let's begin. Cassini's original observations were almost mystical. Using the rudimentary yet powerful telescopes of his day, he could see a point of light circling Saturn, but sometimes that point of light would vanish. No one had ever seen a moon disappear before. Cassini was stumped. At first, he thought it might be an issue with his telescope. Maybe it wasn't strong enough. Maybe Saturn's rings were blocking the view. But night after night, he confirmed the same thing: the moon appeared and disappeared with a strange consistency. Eventually, Cassini figured it out. The moon, later named Iapetus, was tidally locked to Saturn, just like our moon is to Earth. That means one side of Iapetus always faces Saturn, and the side that faces Earth changes as it orbits. One hemisphere is incredibly dark, while the other is bright. So when the bright side faced Earth, it was visible. But when the dark side turned toward us, it effectively disappeared. This observation, simple as it might sound now, was groundbreaking. It was the first time humanity detected a surface property, albedo contrast, on a moon outside the Earth-Moon system. Over the centuries, this bright dark pattern intrigued astronomers. But it wasn't until spacecraft like Voyager and later Cassini arrived that we got a closer look. Fast forward to the 2000s. The Cassini spacecraft, named after Giovanni Cassini himself, finally entered Saturn's orbit in 2004. For the next 13 years, it studied the planet and its moons. Iapetus was high on the list. In September 2007, Cassini conducted a targeted flyby of Iapetus, getting as close as 1,640 kilometers from the surface. What it saw was astonishing. This wasn't just a moon with contrasting faces. It was a world with an identity crisis. Iapetus' shape is distorted like a walnut. The Guinosu, a massive ridge that wraps halfway around its equator. At its peak, it towers 20 kilometers high, taller than 3 Mount Everests stacked. The ridge is ancient and heavily cratered, suggesting it formed early in the moon's history and has remained unchanged for eons. Cassini's instruments also measured the density of Iapetus, about 122 times the density of water. That's very low, indicating the moon is made mostly of ice with some rock. There's no evidence of subsurface oceans like Europa or Enceladus. Iapetus is cold, quiet, and ancient. Its orbit is also strange. Iapetus orbits Saturn at a great distance, 3.5 million kilometers away, far beyond Titan and other major moons. It's also tilted at 15 degrees from Saturn's equatorial plane. These factors make Iapetus less influenced by Saturn's magnetic field and hint that it may not have formed in place. Perhaps it was captured or it migrated. But one of the most stunning revelations from Cassini was the cause of the moon's eerie duality. Let's talk about Iapetus's most eye-catching feature, its two faces. The leading hemisphere, the side that faces forward as Iapetus orbits Saturn, is dark. Not just dim, but as dark as charcoal. Known as Cassini Regio, this area reflects just 3 to 5% of sunlight. The trailing hemisphere, the rear side, is bright like ice or fresh snow, reflecting 50 to 60% of light. This makes Iapetus home to the most extreme albedo contrast of any object in the solar system. The effect is surreal. It's like night and day on the same rock. But how did this happen? Early theories propose volcanic eruptions on Iapetus's surface, dark material oozing up and coating one side. But Cassini debunked that. The dark material is a thin coating just a few centimeters thick. Beneath it is bright ice. So if it didn't come from within Iapetus, it must have come from outside. Enter Phoebe. Phoebe is a distant moon of Saturn with a retrograde orbit, meaning it moves opposite Saturn's rotation. Over billions of years, micrometeorite impacts kicked up clouds of dark dust from Phoebe. That dust, thanks to solar radiation and the Poynting-Robertson effect, that slowly spirals inward towards Saturn. And guess what? Iapetus's leading hemisphere acts like a windshield. It plows headfirst into this dusty stream. So the dark coating, its cosmic pollution, literally, Phoebe's ash is smeared on Iapetus's face. But it gets weirder. That dark dust absorbs more sunlight, making the surface warmer. Slightly warmer, but enough to cause ice to sublimate, turn from solid directly into gas. Since Iapetus rotates very slowly, a day lasts 79 Earth days. Sunlight has time to heat the dark areas, evaporating ice. Where does that water vapor go? It floats to cooler regions like the trailing hemisphere and refreezes. Over millions of years, this creates a feedback loop. Dark areas get darker and drier, while bright areas get brighter and icier. It's the ultimate self-reinforcing contrast caused by a mix of external dust and thermal physics. And it's still evolving. Now let's talk about Iapetus's strangest feature, the equatorial ridge. Nothing else in the solar system looks like this. A straight mountainous wall wrapping halfway around the moon's middle like a belt. Stretching 1,600 kilometers and rising 20 kilometers, it gives Iapetus its walnut-like shape. But where did it come from? There are a few leading theories. Theory 1, fossil bulge from fast rotation. In its youth, Iapetus might have spun rapidly, maybe once every 16 hours. This would have caused its equator to bulge from centrifugal force. As the moon cooled and slowed due to Saturn's tidal forces, the bulge could have collapsed downward, creating the ridge. This theory explains the ridge's alignment and age. But it requires Iapetus to cool and solidify while spinning fast, something hard to model. Theory 2, ring collapse. Another idea is that Iapetus once had a ring formed from a moonlit collision or captured debris. That ring may have collapsed onto the equator building up into the ridge. This aligns well with the ridge's position and composition. But we've never observed a moon with a ring before, so this theory pushes boundaries. Theory 3, sub-satellite impact. Maybe a small moonlet orbited Iapetus. Over time, it spiraled inward and crashed along the equator, spreading debris that formed the ridge. This would be a rare and dramatic event. Rejected ideas, tectonics or impact. Scar, tectonic activity, or a linear impact are unlikely explanations. The ridge is too consistent and too massive. Cassini's imagery shows the ridge is old and heavily cratered. Some sections have landslides or collapsed segments. It's ancient, frozen, and fossilized. It may be the only feature of its kind in the solar system, a monument to a moon's mysterious past. So what can we learn from Iapetus? First, moons are not boring. They aren't just passive lumps of ice and rock. They are dynamic, interactive parts of their planetary systems. Iapetus shows how external factors like Phoebe's dust can reshape a world. It also reveals how small temperature changes can trigger large-scale transformations through feedback loops. Second, Iapetus's ridge reminds us that some events in the solar system are unique. Whatever caused that ridge-fast rotation ring collapse or impact it hasn't happened anywhere else. It's a reminder that even our nearest neighbors can surprise us. Finally, Iapetus teaches us humility. We've only visited it once with a flyby. There are no missions planned to return. Its secrets remain buried under ice and dust. Like many cosmic mysteries, it whispers instead of shouts. But if we listen closely, it tells us of ancient violence, quiet erosion, and the ongoing evolution of alien landscapes. In a universe of glowing stars, dazzling rings, and fiery planets, Iapetus stands out not for its brightness, but for its strangeness. A moon split in two, a ridge no one can explain, a dusty legacy from a backward orbiting neighbor. It used to vanish from telescopes. Now it vanishes from our attention. But it deserves more. It's not just a walnut in the sky, it's a record of the solar system's teenage years, a relic from a more chaotic era. And maybe, just maybe, it's crashing into Saturn's system right now, not physically, but metaphorically reminding us that the solar system is far from finished. So next time you see Saturn glowing in the night sky, think of Iapetus. One face bright, one face dark, and a story still unfolding. Like, subscribe, and stay curious.